Hello friends, in today's lecture
We shall discuss about relative speed, which is very important in terms of competitive exams and board exams. Till now, we have not used relative speed formulas in our problem solving. We shall introduce the formulas here in this lecture. So what is relative speed? Relative speed is defined as the speed of one object as measured from another moving object rather than from a stationary point. In physics, the concept arises from the fundamental idea that all motion is relative. This means we never describe an object's motion in isolation. It's always observed with respect to chosen reference point or frame. If you see in the picture here, the two objects are moving in opposite direction approaching each other. The relative speed is sum of their speed, since both are effectively helping to close the gap between them. On the other hand, these objects on the right hand side, they are moving in the same direction, which means one is chasing the other. The relative speed would be then the difference between their individual speed, which is VA minus VB. This is because the faster object is slowly gaining on the slower one, and the rate of approach is reduced because it has to chase the other object. Now let us see some problems related to relative speed. Car A and car B are moving in the same direction on a highway. Car A is ahead of car B by 2 kilometers and is traveling at the speed of 60 km per hour. Car B is moving at 80 km per hour. How long will it take for car B to catch up with car A? Let us first put this into pictorial representation. So let this be the straight road where car B is chasing car A and the distance between them is 2 kilometers. Now speed of car A, say V car A, is equals to 60 kilometers per hour. So 60 kilometer per hour. And V car B is equals to 80 kilometer per hour. So if you see here, the car B is chasing car A. That means car A is not assisting car B to catch it up. Okay. So hence the actual speed or the relative speed here would be V relative is equals to V car A, V car B minus V car A, which would be equals to 80 minus 60 kmph, which would be equals to 20 kmph. Now the distance between them is 2 kilometers. And speed would be equals to distance by time. Now what is asked here is the time to be found out. But why I have written this is that this speed here is the relative speed which we have to use in our calculation. So V relative is equals to distance by time. Hence time would be is equals to distance by V relative. Equals to 2 divided by 20. This would give me 0.1 hours. or 0.1 into 60 minutes, which would be equals to nothing but, let me just write it down here, would be equals to 6 minutes. So this is our final answer. Let's see our next problem with respect to relative speed. Train A and train B are moving towards each other on parallel tracks. So there is a parallel track on which both the trains are moving. Train A is moving at 50 kmph and train B is moving at 70 kmph. If the distance between them is 240 kilometers, in how much time they will meet? So if this is the point of train A, current point, and if this is the point of train B, the distance said between them is 240 kilometers. Now, speed of train A, VA, is 50 kmph and speed of train B is 70 kmph. Now, as they are moving towards each other, that means they are trying to close the gap between them. Hence, they are assisting each other in closing the gap. So, the relative speed would be equals to then VA plus VB. So, V relative is equals to 50 plus 70 kmph, which would give me 120 kmph. Now, what is told here? How much time, after how much time they will meet? So, as we saw in our last problem, time would be is equals to distance by relative speed, which is VR here. Now, distance between them is 240 and relative speed is 120. Hence, it will take 2 hours to basically cover this distance where the train A and train B will meet. Let us see our next problem. Two runners starts from opposite end of 500-meter track and run towards each other. Runner A runs at 3 meter per second and runner B runs at 2 meter per second. So this is similar kind of problem which we have done now. So this is one end of the track, this is the other end of the track. Now they are separated by 500 meters and speed of the first runner, say V1, is equals to 3 meter per second and speed of the second runner is 2 meter per second. Now they are running towards each other. That means they are trying to close the gap between them, which means both of them are assisting each other to close the gap. So V relative would be in this case V1 plus V2. So V1 is 3 and V2 is 2, which would give me effectively 5 meter per second. Now what is the distance between them? Distance is 500 meter. Hence the relative speed, or rather we can say time required, would be is equals to distance divided by V relative, which is equals to 500 divided by 5 meter per second. So this would give me 100 seconds, and this is our final answer. Let us see one more problem in this relative speed lecture. A 200-meter train A is moving at 72 km per hour. Okay, so a train which is 200 meter long, it's moving at 72 kilometer per hour. So here you observe one thing, this unit is in kilometer and this unit is in meter. So either we have to convert this or this to make our calculation easy and suitable for the units to be in symmetry. It overtakes a 150 meter long train B that is moving in the same direction at 54 kilometer per hour. How much time will train A take to completely overtake train B? So let us do one thing. First convert the speeds. So VA, which is the speed of train A, 72 kilometer per hour. Now I can convert this to meter per second by simply multiplying it by 5 by 18. You can see my beginning videos or initial videos on speed why this is 5 by 18, and then if we do this it will convert this into meter per second. Now 18 into 4 is 72, so 4 into 5 is 20 meter per second. Similarly, let's convert for VB, which is 54 kilometer per hour. So 54 into 5 by 18 will give me meter per second. I mean the speed in meter per second, and then 18 into 3 is 54, and then 3 into 5 is 15. Hence 15 meter per second is the speed in meter per second. Now of train B. Now the train A overtakes a 150 meter long train B that is moving in the same direction. So if I consider the train B or rather say a train B which is 150 meter long, let this be the distance representation. This is train B, and then the train A which is basically 200 meter long. So let this be the 200 meter long representation of train A. Notice here one thing, if train A has to overtake train B, if the engine part comes here, then it has to travel another 200 meter to completely go ahead of train B. Hence the total distance which needs to be traversed by train A would be is equals to 150 plus 200 meter. So 150 plus 200 gives me 350 meter. Now here if you see, the train B is also moving in the same direction. That means it is not assisting the train A to catch up with it. Rather, it is opposing. Hence, the effective speed of or the relative speed would in this case would be VA minus VB, which is 20 minus 15 meter per second, which is equals to 5 meter per second. And the time required would be is equals to distance 350 meter divided by speed, relative speed 5 meter per second. So this would be effectively 5 into 7 is 35, 70 second is our correct answer. So that's it for this lesson of relative speed. I hope you liked the video. Please like, share and subscribe, and see you next time. Thank you.